Hey there. Now we talk about something very, very important. Everything's important, but this is super important because we talk about what you can do and what you can't do when you're adding or subtracting polynomials. It's not incredibly hard, but it's very easy to make mistakes. And so that's a different thing. It's not hard to do, but people generally make mistakes on this stuff. They start adding things they shouldn't. Now, we spent a whole long time talking about what polynomials were, and what terms were, and what that meant, and what the degree was, and most importantly, what like terms are. So here's what we learned the very last statement in the last video. You can only combine like terms. Well, polynomials are added or subtracted by appropriately removing parentheses and then combining like terms. That's what we're going to learn today. What appropriately removing parentheses means over this video and next video, and then how to combine like terms. Is it hard? No. Is it easy to make mistakes? Yes. So it's something that is not mathematically difficult to do, but it's something that takes a lot of focus and a lot of checking your work and being very diligent in doing your math correctly here. So let's take a look and explore everything we've learned so far. So what does it mean to add polynomials? Well, it means you have two polynomials with a plus in between them. Now, right off the bat, please notice that if this plus is not there, that is a different operation and we'll be multiplying. We're not there yet. So when we have that plus, that's what's telling us you're adding polynomials. If it's a minus, we're subtracting. What we're not doing here, and you might have heard this, we're not foiling or distributing. That is not what's going on with these polynomials because we are not multiplying, we are adding. So why are the parentheses even there? Well, the parentheses are there telling us this is where our polynomials came from. We had one polynomial, you had another polynomial, and now I want to add them. Both of them have, and hopefully we know this, both have two terms. First term is 4y, the coefficient is 4. Second term is -6, it's a constant. First term is 5y, coefficient of 5. Next term is -3, that's a constant. Degree of 1, this polynomial has a degree 1, so does that one. They're both considered linear polynomials. Oh my gosh, like that one thing we learned a while back, like linear, one variable, a variable with exponent of 1. Anyhow, when we're adding polynomials, the first thing we need to know how to do is to get rid of the parentheses. Now, it's not horribly hard to do, we just have to be very careful about one thing. If there were any numbers out front, well, what number's out front? What's 1? We would have to distribute those numbers. That's going to happen later when we talk about multiplying monomials times polynomials or polynomials times polynomials. We'll have to distribute before we combine like terms. So this is a growing process for us. We're going to start adding more steps to it. So right now it's really important to get this down before we start to change it. So firstly, if this is one polynomial, the number out front is really just 1. So while I'm not distributing one polynomial times another, I may have some factors out here, some numbers that do need to be distributed. But if you distributed 1, multiplying by 1 doesn't change anything. So this parentheses really isn't doing anything. Even if you distributed the 1, would you not get back 4y minus 6? In the same manner, there's also a 1 right there. Well, if you distribute that positive 1, would you not get back positive 5y? Remember, every time we say positive, we write plus. And -3, every time we say negative, we write minus. You'd get back exactly the same thing. In general, that's what happens when you're adding polynomials. The parentheses basically just annihilate, and you distribute 1. It's not changing anything. They're just housing the polynomial saying, yeah, you're going to get this back. Yeah, you're going to get, this is where it came from. Now, I do have an important question. What if that wasn't a plus? What if that was a minus? What would happen here? I answer that question in the next video. So we'll talk about how to subtract. I separated the videos because I want to specifically address it so we have no one skipping it because it's really important. It's where all the mistakes come from. I'm not even joking, like 95% of mistakes come from when that's a minus. It's almost never adding, almost never. Now, oh man, now it's great. So once I get rid of my parentheses, now I have 4 terms. Now we can go through and say, hey, are there any like terms? One piece of advice I'll start with is Start by trying to combine the like terms to the largest degree. If you do that, you're going to have your polynomial in what we call order. So we want polynomials to have exponents that are descending, to have terms where the degree is descending. Largest ones first, and then smaller ones second and third, and likewise until you get to the constant at the very end. That's very common. It's a good setup because it leads to good factoring, it leads to good use of formulas, it leads to understanding graphs better much later on. So we're going to practice that now. So I'm going to look for the variables with the largest power. Here I only have 4y. Oh, wow, look at that. I have 4y. Now, are there any other terms with exactly the same variable part? Because that's like terms, like we learned in the last video. Well, I see a 4y. That's one term. I also see a positive 5y. Now, you're going to notice a technique thing right now. The technique I do, I've been doing this for a lot of years. Even when I was younger, when I learned this, I always circle the like terms with the sign in front of them. I do it for two reasons. Number one, in my head, like psychologically, I see this better. I understand that's positive. If it were a minus, I understand it would be a negative when I circle it. It leads to much fewer sign errors for me. Secondly, when I combine like terms, and we absolutely can here, combine like terms, well, then I can cross them out, and I'll have to look at it again. So when you combine like terms, you go, hey, 4y and 5y, those are like terms. Positive 4y, positive 5y, that's like terms. Now let's combine them, let's add them. How in the world are we going to do that? Well, this is going to be so cool. I'm so excited about this. What you do with exponents is one level below what you see. I've been preaching that for a long time. So if you saw the order of operations exponents, you multiplied. If we saw multiplication, we added. When we see division, we're going to be subtracting. What happens when we see addition? This is addition subtraction. What do you do with the exponents of 1 and 1 when you add? Well, let's think about that. What's below addition? And I'm not talking subtraction. Those are on the same level. What's below addition? Nothing. So what do you do with the exponents when you're adding or subtracting terms? What do you do with the exponents? Remember, exponent rules only deal with exponents. And what we do with exponents is one level below what we see. This is huge for you, okay? When you see exponents, you multiply. When you see multiplication, you add the exponents. When you see addition or subtraction, nothing. There's nothing to do to the exponents. So what do you do to the exponents when you're adding or subtracting? You can't do anything, which is why they have to be identical in order for you to add them, because you can't change them through addition subtraction. That is enormous. I'm going to say that one more time. What we do with exponents is one level below what we see. So exponents, you multiply, multiplication, you add. If you see addition or subtraction, exponent rules apply only to exponents. If you see addition or subtraction, there's nothing below that to do. So by adding or subtracting terms, you cannot change the exponents. There's nothing below addition subtraction. There's nothing to do with the exponents. So if you can't do anything to the exponents, you can't change them at all through addition subtraction, they'd have to be exactly the same. Because in order to not change anything about them, they'd have to be identical. That is why we can only add or subtract or combine like terms. Because through addition subtraction, you can't change the variables, you can't change the exponents, which means they'd have to be identical for you to combine them through addition subtraction. That's a big deal. So if we're going to combine these, then we're really just simply adding the coefficients. You get 4y, you get 5y. If you add them up, you have 9y. Notice what you don't get. You don't get 9y squared at all. You added the 4 and the 5. You don't also add the exponents. Think about why you can't add the exponents, because if you did, adding exponents has this connotation of you were multiplying. We're not multiplying. You're not getting 20 at all. You're adding the 4 and the 5, but there's nothing to do with the exponents below that. So doing anything with exponents would be clearly wrong. If you put power 2, you would have had to multiply y times y to get the power 2, but you're not. In fact, if you get a power 2 here, it would have only been through 4y times 5y, but that wouldn't give you 9, it would give you 20. And that would give you y squared for sure. But that's not what we're doing. We're adding, we're subtracting. These are terms connected through addition subtraction. So we're not multiplying, hence we can't add exponents. We're not multiplying, so we can't add exponents. We're adding, so we can't do anything with the exponents, which is why they'd have to be identical to be combined. So what do we get? We just get 9y. You had 4 of them, you had 5 of them, now we get 9 of them. That's it. Don't do anything with the exponents. There's nothing below addition, subtraction to even do. I like it because we can cross them out, and then we move on to one exponent class lower, so 1 degree lower. Now it's our constants. I've got a -6. Notice how circling it makes me take the sign. I've got a -3. Just add them. -6 plus -3. Well, that's -9. If I say negative, remember the idea of terms. Terms always go with the sign in front of them. So the sign of our term creates the sign in front. So -9, we translate that back to -9. The reason why we're translating, I showed you last time very quickly, but because you could always add terms like this, one term is 9y, the other term is -9, but the addition of a negative is the same thing as subtraction. So when we say negative, we just translate it back to a minus sign because the idea is all wrapped up in that term. So having the 9y plus -9 is the same as 9y minus 9. So even though we get a -9, we write it as a minus. We still have the same idea. Now it's time for a practice. We'll walk through them a little more quickly. The main things to focus on here are find like terms. Make sure that you are not changing your exponents when you're combining like terms. You can't. There's nothing below addition subtraction on the scale of order operations. So what we do with exponents is one level below what we see. If we see addition subtraction, which is what we see all up here, then there's nothing to do with the exponents. If you can't change the exponents, they'd have to be exactly the same to not change them. So only combine like terms and do not change the variable part. That is how you add and subtract polynomials. Let's practice. Here we have two polynomials. One is 2x minus 7, the other one's -3y plus 2. They each have two terms. The degree of each polynomial is 1. You know what? I'm going to change that to a... Let's change this to an x. Otherwise, you wouldn't be able to combine those. So let's change that to an x. The coefficient of our 2x is just 2. Here we have a constant of -7. The coefficient of our -3x is -3. Our constant is +2. Now, let's be real careful about removing parentheses. Let's look out front. This is really just a +1. Now, while we're not distributing the polynomial to the other polynomial, you could think of distributing a constant through that. Distribute 1. None of your signs are going to change. Distribute +1. Now, notice why I'm doing this. What I don't want you to do is start writing really weird stuff. Like some teachers think that it's okay to just say, well, drop the parentheses. That's a really bad idea. Because what happens when you drop the parentheses is you start getting weird stuff like this. Like -7 plus minus 3x. Ain't nobody understand that, okay? You don't got time for that. That doesn't make any sense. You never have two operators next to each other, ever. What you can do, you could put this as -3x, and then go back to what I showed you here and say, well, then you're adding a negative. You could put subtraction, but can't we just do that all at once by distributing the +1? Because if we do, we go, okay, well, +1 times -3x, well, that's -3x. I say negative, I write minus. You should never, ever, ever write more than one operator between two terms. It needs to be either 1 plus or 1 minus. If you write plus negative, that's fine because that's an operator with a sign. That's okay. That changes to a minus, but never ever write two operators between two terms. It's always 1. For us, it's very much easier just to say, yeah, +1 times -3 is -3x. I say negative, I write minus. Lastly, +1 times +2, well, that's +2. I say positive, I write plus. That's how we appropriately remove parentheses. It's not about dropping parentheses. It's about focusing on what number's actually in front of them, distributing appropriately, and writing the result in term format with one operator between them. That's how to remove them. Now we go on to, let's combine some like terms. Let's look at the biggest powers first. Well, all I'm noticing is a +2x. Are there any other terms that have exactly the same variables? Any like terms? Well, I'm noticing another one, but watch what happens. When I circle it, I circle it with the sign. Now, we can combine like terms simply by adding the coefficients. So even if you took your calculator out, you could do this. The coefficient is 2. That's why we talked about coefficients. The coefficient is negative 3. 2 plus negative 3. What's negative 1? Now, negative 1x. When you're adding or subtracting like terms, you can't do anything with exponents. Exponent rules say what you do with exponents is one level below what you see. If you're seeing addition, subtraction, there's nothing below that to do with your exponents. So you leave them the same. That's why they had to be the same in the first place, so that you could leave them the same and not change them. So 2x minus 3x, or 2x plus negative 3x, is negative x to the first. Just don't change your variable part when you're combining like terms, ever. Let's cross that out. And then we have, well, I see our constants. Constants are always defined as like terms. We talked about last video. Negative 7, positive 2. That's our terms there. If we add them, negative 7 plus 2 is negative 5. I say negative, I write minus. Now, you can write this in the interim, so like, oh, it's negative 1x. But normally we don't leave that 1. We just consider this to be negative x plus 5. That's appropriate. Now, can you go further? Could you combine these? Well, no, they're not like terms. What I do with the exponents is, well, I keep it the same, but you'd have to have the same exponents to keep the same. You can't combine these. You also can't combine these. They're not like terms. You cannot combine terms that are not like terms. I hope this is making sense. I hope that you're like, yeah, I understand polynomials. I understand the distribution of 1. It doesn't change signs. It allows you to appropriately remove parentheses, and then we're combining the terms that have the same variable part. Same variables raised to the same power. How we do it, it's very simple, but it's very easy to make mistakes. It's simple in that you're just adding coefficients. It's easy to make mistakes in that a lot of people want to add the exponents. You can't. If you're adding the coefficients, you can't also add the exponents. What you'd be doing is one level below what you do with the coefficients. If you're adding coefficients, you'd be doing one level below to the exponents. There's nothing to do, which is why they have to be the same in the first place. Okay, next up. I'm going to move a little bit quicker on this one. In fact, if you want to try that, now would be a pretty good time for you to pause it and just give it a try. If I put a 1 there, that's really what I'm distributing if I'm distributing anything. That would be positive x squared, positive 3x, so I put plus, negative 7, so I put minus. There's also a little 1 right there. Now, I'm not distributing these terms to these terms. That would be multiplication. We're not doing that. But I can think about this as distributing my positive 1 through the next terms in those polynomials. So positive 1 times negative 4x squared, well, that's negative 4x squared. I'll write minus. Positive 1 times negative x, well, that's negative x. Positive 1 times positive 2, well, that's plus 2. Now we can go through and combine some like terms. Remember what like terms are. They are only terms with exactly the same variables raised to the exactly same powers, the same variable parts. Start with the big ones. Keep it in order. So I'm going to look at x squared, and I'm going to look for any other terms that have the exact same variable part. I see a negative 4x squared, so I'm circling them. Like terms are always combined through just adding the coefficients. So coefficient here is 1. Coefficient here is negative 4. So let's see, 1 plus negative 4, that's negative 3. And if I'm adding or subtracting, what I do with exponents is nothing. They have to stay the same. They have to be the same because they have to stay the same. Cross them out, keep going. Now we'll look for anything with 1 degree less. So any x's. I see a positive 3x. I see a negative x. So coefficient of 3, coefficient of negative 1. So 3 plus negative 1, that's positive 2. I say positive, I'm going to write plus. Notice how we get different terms. You have to separate them by pluses or minuses. And then, let's see, I'm adding or subtracting. So what I do with the exponents is one level below. So if I'm adding and subtracting, I'm doing nothing with the exponents. I'm keeping them the same, which is why they had to start the same with like terms. Lastly, constants are always like terms. So negative 7 plus 2, negative 5, we write minus 5. I can't go any further. None of these are like terms. I can't combine them. We're done. It's in order. It looks really good. I now have a polynomial with 3 terms, coefficients of -3, +2, constant of -5, and a degree of 2. Kind of cool. Okay, last one. I really hope that you did it on your own. If not, it's okay. We can do it right now. If you were to distribute a constant, that constant would be 1. That constant factor would be 1. It would not change anything, but it's good practice to look and say, what's out there? What am I really distributing? Because later, you're going to have numbers there. Now, nothing changes. No signs change. But we're appropriately removing parentheses by considering distribution of a constant factor. Same thing here. I want you looking here. I want you to see if there's a plus there. If there is, that +1 gets distributed. +1 times x to the third is positive x to the third. I say positive, I write plus. Terms must be separated by addition or subtraction. So writing like this, you're like, oh, it's just right there. Well, that's a problem. Do you see how it created a term out of 2 things that were different terms? That's an issue. So we always want to separate. We say positive, we write plus. +1 times -3x is -3x squared. Well, we're going to write minus. And +1 times 3 is +3. We'll write plus. Let's keep on going. Let's keep this in order. I'm looking for the largest powers now. So I'm looking at x cubes. I notice a -2x to the third. I notice a positive x to the third. We always consider terms with a sign in front of them. Well, let's combine them. Coefficient of -2. Coefficient of +1. Let's see, -2 plus 1. That's -1. -1. What I do with the, so I'm adding, subtracting. Notice what you just did. You just added. What I do with exponents is 1 level below what I see. I just added, so I do nothing with the exponents. There's nothing below addition to do. So if I do nothing with the exponents, they stay the same, which is why they had to start the same to remain the same. X to the third. -2x to the third plus 1x to the third is -1x to the third. After that, I'm going to look for the next largest power. So I'm looking for any x squareds. Now I see one, but I don't see any others. That's okay. If there's no like terms, then just leave that term. So if I have plus or +2x squared, I have nothing else to combine. Let's just put plus 2x squared. There's no other x squared terms to combine. Next, I'm looking at x's. I see a -5x. I see a -3x. -5x. So the coefficients are -5 and -3. -5 plus -3. Notice I'm always combining like terms through addition of coefficients. That's -8. I say negative, I write minus. What I do with exponents, 1 level below what I'm seeing on the paper. So 1 level below addition is nothing. They remain the same. Lastly, constants are always like terms. You can always combine them if you have more than one. -7, +3. So -7 plus 3, it's -4. I write minus. Lastly, just remove that -1. That's in order. It looks really good. I have no other like terms. That's combining like terms, folks. That's how you add polynomials. Now, the next video, we'll talk about subtracting because I want to make sure you understand what the difference is if that's a plus or a minus. Now, I already prefaced it by saying, hey, you kind of distribute it. It's going to affect your problem a little bit differently when you appropriately remove parentheses. I'll show you how that's done when we get to the next video.